Alright, welcome back. So we got a lot to do today. We're going to be figuring out why the route is being exported but is not properly being imported. The other thing we're going to, so hopefully that will be the end of, well, actually never mind, because if we get that done, we can move on and do the next example for Interprovider VPN, and then hopefully move on to the next topic. But so far this has been a really good learning exercise in my opinion, so let's keep going. Okay, and I'll start by making the title. Oops, so it looks like I might have said that, oh, yep, nope, carrier is done. Okay, yep, so I'm on Interprovider. And this is going to be the fourth video. Now, I had initially planned to take this exam in November, but I will be having a break from work for the holidays. So I might push back my test date to December so that I don't have to take an extra day off of work. I'd rather just do it on a day I had off already. But I haven't checked in yet. I mean, I was told when that week was, but I didn't write it down or anything. So I gotta verify when that week is, and then if that week is a day I already have off, that's the day I'm gonna take the test. I can do that today. Okay, but let's dive right into where we left off in the last video. So we left off on router C, and we did a show route advertising protocol BGP. Oops, but before I do that, I need to make sure I know which neighbor to specify. So I'm going to be specifying the eBGP neighbor right here. So let's go back to the show route advertising protocol BGP. Okay, so now you notice that we're advertising a special L3 VPN route. So the first thing I wanted to check in this video is what kind of routes are allowed to be imported into router D, and if it's not allowed to import L3 VPN routes, I think that's the problem right there. So hopefully there'll be a way to add that. So let's just verify that it's not showing up again. So show route receive protocol BGP, and then oops, it looks like I highlighted. So it's going to be .1. Or .21. There we go. So yep, you see we're not getting anything. So let's take a look at the import policy. So show configuration, protocols BGP, pipe display set, pipe no more. Okay, so it looks like we don't have a import policy. We do have family iNet VPN unicast, which I think that's the kind of route this is. So that's surprising. Let's go and see if there's some other options under there, and maybe this isn't the right option. Now I know some of the other options were used, but let's just see what options there are. Okay, yeah, so that definitely seems to be the right option. Let's take a look at router C and see what options are configured there. Okay, so router C, we have iNet VPN unicast, just like router D, so that doesn't seem to be the problem. Okay. Yeah, so everything seems to be fine. Now, okay, yep, and we've got the keep all as well. Okay, well that's really weird. Now, if I can't figure this out, what I might do is pull up the official troubleshooting strategy by Juniper, and then go through step by step. I'd rather just do that, even though it might not be useful, than just kind of struggle and fail. Okay, so we've got a different naming convention used there. That's why there's so many differences. But everything else is the same. Let's see if router D is advertising a route. So we've got show route advertising protocol. Yep, we've got a route going that way. All right, let's take a look here. Yep, and we've got a route going this way as well. So clearly, yeah, let's see if it's received here. Nope. Okay, so let's do a Google search, because I'm going to need to learn brand new here what's going on. So we're going to do Juniper L3 VPN route not learned over eBGP. Okay, so I've got some decent ones here. I'll make sure to include the one I use in the notes. Now there will be rules for how a route gets installed. We can look those up, but here's some common L3 VPN problems. Now, one thing I'm interested in, so yeah, this is exactly right. This is the route I want to exchange, because I want to ping end to end. So this autonomous system is going to need to learn about this, and router F is going to need to learn about it as well. Likewise, the other way around, it looks like the issue is just that, you know what? I think the problem is that the next hop for this route isn't set correctly. So it's set to self. I wish you could do like a no resolve, because like self to me just isn't explanatory enough. I mean, it's nice to know that it's on self, because if they just give you a random IP without looking into it further, I wouldn't be able to tell if it was configured here or not. So self is a pretty useful word to use, but the only problem with it is when this gets passed on, whatever was used for this self here is going to be used after it's passed on, unless I have a configuration that resets this. Oh, and you know what? eBGP automatically. Oh no, because this is advertising. So yep, it's advertising this route with the next hop of self, and clearly that next hop is not going to be valid on router D. And I think that self is going to be the local address too. Like if I took off. Okay, so we've got no local address. So I'm not sure what that is. Let's do a show route detail on that. Okay, so let's try to figure out what the next hop is on this, because when it gets passed over to router D, BGP is a bit different than other routing protocols, where it doesn't actually pass a route that's ready to go into the table. It passes basically abstract data about the route. That's what helps it scale it up so fast. So it's called network layer reachability information. So the information in that does not automatically change to be information that is valid to create a route. It's sent as it was created, and then if it needs that change, you as the administrator have to make sure that that you include the correct knobs and switches to have that change be made in the way it needs to. It doesn't happen automatically as it does for IGPs. Okay, so yep, I want to do maybe detail. Yeah, here we go, perfect. So now hopefully we can see the next hop for this. So we've got the, okay, so the next hop is probably, well, I don't know. Let's do pipe match hop. Ah, here we go. So yep, I was right. It matches the router ID, so this is the next hop. Clearly, when it gets to router D, that's not going to be a valid next hop. That route's not in the table. It's not learned in the table. So if I do a show route on that, we've got nothing. That's because that is, if I look at here, that is the address on LO0, and that is not being included in our advertisements in eBGP. In fact, we're not advertising any routes. We're only injecting routes into the protocol from router A. So let's take a look at where I did that. We'll take a look at the kinds of routes that are being injected. Okay, so we're gonna export attached routes. So anything directly connected, which is kind of interesting that this route didn't make it through. It's actually very interesting. Why is this route not here? Yeah, why is there only one? How come this 10.10.10.1 made it all the way here, but this one didn't make it all the way there? Huh. Yeah, that's interesting. I wish I knew the answer to that. Let me know in the comments. I think the issue is that the next hop is not valid. You can see clearly that it's not in the routing table or anything like that. So the route just never makes it into the table because it doesn't meet, it's not eligible because it doesn't have a valid next hop. Okay, so let's add some configuration to the eBGP group to modify the next hop so that it can be installed in the table. I do believe that's going to fix the problem. Oh, you know what? I'm gonna need to huh. Okay, so I guess I'm not sure where I would set this. I guess I was thinking that I would. You know what? Yeah. So this is a bit beyond me at this point. So let's see here. Okay, and one thing to notice. Okay, so the next hop does get set to self. Um, I think when it's through eBGP, it's just iBGP where it doesn't automatically do that because there's some different default options between eBGP and iBGP. But I think so let's do a show route hidden. Aha! So now we've got the route. You can see it did make it in there, but it's not a valid route, so it shows up as a hidden route. So let's do show route table. Yep, hidden detail. So, and we should be able to see, aha. So the reason it's not is hidden is because MPLS is not enabled on the interface. Look at that, perfect. All right, I'm starting to feel more confident for the exam because I absolutely, yep, so all we got to do is enable MPLS on this interface and we should be good to go. No, it had nothing to do with the next hop, anything complicated like that, because it's eBGP, so the next hop is automatically reset. Okay, so I'll add that to both sides. All right, and let's just dive right into it, see if we can ping end to end. Okay, so we still got issues pinging end to end, but you'll notice we did make a lot of progress because the last time I tried to ping end to end, and of course I don't have it up anymore, I had a no route to host. I just wasn't getting a route at all. Now I am getting a route though. So let's see what route shows up. Okay, so I get a BGP route, but here I think might be, aha, so here's the problem. You can see the AS path it went through, so now they kind of list the AS path backwards in my opinion. They start with the I here, so this kind of will align with the topology here. So I means that it was generated here, then it traversed through AS path 11. I is kind of like the self keyword in a way, but here's AS path 11, 10045, 10023. Now, the problem here oh, okay, well, never mind. So I thought the problem was that this was also Autonomous System 11, but it looks like it's actually a different autonomous system. It's Autonomous System 9, which I thought these autonomous systems were meant to match. Okay, well, that's interesting. Let's take a look at the details of this. Okay, so yeah, we're having issues here. Let's see what the trace route has to say. So the thing is, since it's MPLS through VPN, it should just be one hop. Oh, but no, never mind. My understanding of that was incorrect. It looks like it is going to be multiple hops, thankfully, because this will help with the troubleshooting. And we can see it had the problem here, 192.168.198.2. I think that's on router C. Let's take a look. Nope. Okay, I guess I'm not sure what it's on. Maybe it's on router B. Let's take a look. Yeah, it's on router B. It's just the local. Yep. So it's gonna have a hop count. Once it's placed into the VPN, that's gonna increment the hop count. But it looks like after it's placed into the VPN, it's having problems. Now, I would think there would be another hop count there when it gets passed through eBGP. Let's go back and look at the same commands we looked at before we figured out that MPLS was missing from one of the interfaces. Okay, so this looks a lot better. We are receiving the route now. Okay, and then there should be no difference. Yep, no difference for advertising protocol. Everything, as far as I understand, looks the same. Okay. So, okay, so AS path 9i, AS path, yeah, 9i because we're on router C, AS path 11.10045, and then I. Okay, well, that's strange. I wonder what the next hop is. Here's the next hop. Okay, so yeah, everything seems to be fine. So it almost looks like the issue is happening on router B because there weren't any extra next hops. So let's just do some basic checks on router B. So let's make sure BGP is up. Yep, looks good. Let's make sure RSVP neighbors are established. So, I mean, BGP is up, so all of this other stuff is going to be up as well because it depends upon BGP. I'm kind of doing it backwards in some way. The MPLS LSP could be down with BGP up, I believe, but it is up. So, yeah, I'm not sure. Maybe I got the, so here's the community. What's the community? Here we go. So target 100, 1001. Okay, so community unfortunately is not, yeah, it's not a part of the config there. Yeah, so community is only going to go there. Yeah, I'm really confused what is going on. And fortunately I do have some time left. But yeah, I'm completely stumped. Yeah, so you can see the import statement here. We're only going to be importing stuff that match the community string here. But the good news is that is the community string that is being used. Now, if it were the case that I had 1001 and 1002 over here, then the routes would not be imported because the community did not match. But that's something I haven't done yet. I think that's going to be a good step, is to look. Yeah, let's look at the route. Okay, a detail. Let's do a show route hidden, just in case. There shouldn't be anything in there, but okay, yeah, there's nothing in there. So let's go back and print that out. Okay, so let's do this. We're going to go step by step, and we're going to just trace the L3 route through every single router. Won't skip a single router, and see what we come up with doing that. Okay, so we're going to trace the route 10.10.10.2. So let's go to the next hop. The next hop is going to be this address, which is the directly connected address on router B. So let's just verify that. Okay, so yep, that looks good. So yep, let's take a look at the route in question now. Oh, so it's a lot bigger now because that's interesting. Yeah, why is it so much bigger? I think the reason it's bigger is because there's VPN. Yep, there's VPN information now because it's part of a VPN. Here there's no VPN information. So let's see if we can get the name of the VPN it belongs to. Okay, I don't see it offhand, so let's do a filter. Okay, so we can see the table it went in, but we can't see the... I was looking for VPN-A. I thought that would show up somewhere. Okay, but it appears to be fine. Let's see what the next hop is. So the next hop is going to be 10.0.1.2. Okay, so it's just the other side. Let's go to router C. Yep, so the next hop is the directly connected interface. Let's see what this looks like. Now, I would not be surprised if this didn't show up. Aha, it did not show up. And if it were also not in hidden. Yes, and the reason for this is because if we look at the route table, yep, we've got routes, no question about it, but we've also got labels. So this is being passed from router B to router D, to router, well, let's look it up. Okay, so it's being passed to here, which I think is router C. Let's check that. Yeah, so it's being passed to the loopback address here, router C. So it arrives as a label. Okay. I'm so confused right now. Okay, but it is able to, okay, it takes it out of its label, and we can see what label it is. It's going to be 17. So here it is as a label. Yep, it swaps it for 16. I think that's good. And then here's what it's like when it's not in a label. It's a L3 VPN route we can see. Okay, so let's go to the next router and do the same exercise. Now, similar to router C, we actually won't see the route, and that's because it is a L3 VPN route now. So this command should be similar to router C, where there's no output. Perfect. And hidden won't have any output either. Perfect. Okay, so, but just like router C, we will see information for that route. If we do a just a regular show route, and then we can see the label information. We can also see it in the BGP L3 VPN.0 table. Yep, and we've got two routes in that table. Aha, and it looks like I found the problem. So at the top surface level, the problem is that, oh wait, never mind, no. I thought there was only one of these on this, but there are two. That would have been the problem if this was only showing up once. But we can see it is there twice. We're focusing on the .2 one, which is down here. Because, yep, we started off with .2 over there. And we can see, yes, it is being passed correctly. Let's see what the next hop looks like. Next hop is .177. Okay, so let's see where this next hop shows up. I have a feeling it's the loopback of router E. Okay, we do have the route here, but it's learned through OSPF, so let's go over to router E, and I believe that will be the loopback. Yep, it's the loopback. So, okay, let's do the same steps we did before. Okay, so now we have it showing up, of course, just like before. We've got the next hop going over there. So, what the heck is going on? Why is it not working? Yeah, I'm like really confused. I don't know. I might need to do some Google searching. Okay, so over here it's actually configured on the router, so it's a directly connected route. Alright, so let's just do the same thing for .1, and hopefully it'll show up in a similar way. So yep, .1 was learned all the way across from the other side. Oh, so we're already kind of there already then. I mean, if it's successfully learning it from the other side. Oops. So I can ping myself, I just can't ping across the wire. So let's see here. Juniper OSP kit. Alright, let's see what that route looks like again. So, yep, it's just a BGP route with the next hop. Yeah, and the trace route unfortunately gets caught here. So it makes it here, but once it goes in the VPN, it's trash. So it makes it past this hop, but then it goes into the VPN and it can't, it doesn't work after that. But it does make it all the way over here. I have no idea. I guess maybe like null 0 or explicit null. I need to enable that. Or maybe the one where I was missing MPLS on, I'm also missing RSVP. Alright, let's kind of take it easy and just print out all the show runs and then look through it like that. I think that's easier than just trying to get the right command. We'll start by just seeing if there's any strangeness in the config, such as a interface being enabled for MPLS but not being added to RSVP. Okay, so don't need MPLS interfaces there. Here we do have two. Oh, here we are only going to need one MPLS interface, and we have that enabled for RSVP. But here's where it could get tricky. We're going to have two. Aha! So yep, I think I found the issue. We're going to need that second MPLS interface to also be enabled for RSVP. I think. I don't know if that's true or not, but it's a good place to start. So set protocols RSVP int. Alright, so next step is going to be this side, but here it's going to be 000. Okay, so hopefully this was the answer. Yeah, I didn't think that would be the answer, actually, to be honest. I thought, like, that didn't seem like the right answer because, like, basically all I'm trying to do when I, okay, well, wow, okay, yeah, I have no idea. Do I get more hops when I do that? Let's see that. Okay, still got that same hop. Let's see if I get one more. Don't get an extra hop. Okay, so yeah, that just straight up didn't do anything. I'm kind of tempted to just roll it back. That's really strange. Okay, so there's some differences here. I don't have type external here, but I have a different local AS than a pure AS, so that doesn't matter. I just don't get why I have all of the routes. I just don't get why I have a route in the table, but it's timing out. Yeah, so this is what we're doing here. This is the same topology. So why can't I ping end to end? Oh. I'm so confused. Okay, so yeah, let's follow the labels end to end. I might want to just read this whole thing. Yeah, I should probably just read this whole thing, because this seems like it's it. Although it looks like we've got, like, a whole series here on Interproviders. Yeah, so I can look at different setups here. Oh, that one I already have. I got clickbaited. I don't know what this quirk is, but let me not get clickbaited. Okay. Alright, I guess I got distracted. Clickbait would be more like if he said the Queen of England, or if he said like click this for something great and then just didn't have something great. Yeah, I'm tempted to just read this whole thing. But that's part 2, so let's see, part 1. Yeah. Part 1 might be better for me. And here's part 3. Okay. Yeah, so that's for option C. This is for option A. I'm not sure what happened to option B, but so here's some configuration to look at. Okay, so he's got much more sophisticated topology than we do. Different route distinguishers. Now this is interesting. He's got different route targets. Oh, no, I had different route targets as well. Yeah, it does seem. Oh, yeah, this is router 4, so. That's he's looking at the route reflector. Okay, let's just look directly at his configs. Okay, yeah, this looks all similar. What about this one? Let's see his L3 VPN config. Yep. I mean, it's so strange because like it has the route and it can actually ping, it just times out. Why does it time out? Let's go back to so let's try to ping it again just because I want to. It'll make me feel like I'm doing something. But let's go and say, why does a ping time out? Yeah, so I just wanted to kind of refresh myself on the absolute basics just because my mind is in such a pretzel right now. I just want to know the most simple and basic thing possible. So I guess that could be it. No, but if it were shut down, the loopback address. I think. Oh, what? Oh, okay, yeah. It's not meant to be like that. It's meant to be here. I mean, there's no issue with the route actually getting there. Like, oh, you know what? It says validation state unverified. That could be a clue. Yeah, let's look into that in a bit more detail. Yeah, let's see what this means. Okay, it's doesn't matter. How is it making it here, but I'm not able to ping it? Like, why can I guess what the next thing I'm gonna do. Oh, and I'm almost out of time, so. But I'm just curious. I'm going to see. Well, it's not going to be. I'm going to see if traffic changes. Yeah, so let's see if ICMP traffic, which links it fails to go through. Okay, so there's no changes when I do that. Okay, I can do stop capture. All right, let's see what happens on this link. I guess this is the more interesting link because the next hop failed there. Okay, so we've got hello messages. It looks like, yeah, it's, so what's happening is when I ping the other side, what? Wait, what? Oh, I'm not pinging the right address. Okay, but this confirms it. When I ping the other side, it doesn't even affect. It looks like nothing new happens here unless my capture is busted. Let's try starting it again. Oh, okay, so yeah, my capture was busted, so ICMP traffic is going over that link. That's interesting. Okay, so yeah, let's see if it goes over the next link. Now, I wouldn't think it would go over this link. I would think that it would be a different kind of traffic than ICMP. Nope, it's definitely still ICMP. That's interesting. Now, unfortunately, I won't be able to use Wireshark during the test, but what I can do is use monitor traffic to do basically the same thing. Probably need to get in the habit of doing that, but I've only got 5 minutes now, so I'm just gonna keep using this strategy that won't be valid on test day. Okay, it looks like ICMP is making it through that one as well. Oh, I see. It's because they're sourcing from the wrong address. So I'm gonna stop the capture. Yeah, and now we can see, here's my ICMP traffic. It sources from the physical interface. That's what it does by default. So if I specify the source address, then we're going to have successful pings. So that's the problem. Now that does lead me to wonder why this wasn't being sent across to the other side, because if I do a show configuration pipe display set pipe no more, we can see we are advertising anything from protocol direct, and you can see I do have 2 routes in protocol direct. So why is the other side not learning this second protocol direct route? That might be a good that might be a reason to do a second video, but it did work. I kind of would like to instead just keep moving, because this is now working. I think I have a decent understanding of it, and we can see the source address is required. That's the only thing that was going wrong. Yeah, so I think that's going to be the end of this video, and it's going to be the end of this topic. In the next video, if I do a help apropos, pipe match, help topic, pipe match Interp. You can see that we've got another, so we did the ISP example, but we got another one for EBGP. So in the next video, before moving on to the next topic, I'll do another video, and hopefully this will be a bit easier. There's only 4 routers in this one. I'm not sure what happened to router A and B, but well, there's B, but I'm not sure what happened to why they don't reuse A. So we'll look into that hopefully in the afterwork video today if I can muster it. So thanks for watching, and I'll see you in the next one.